Hello everyone, I hope you are doing well. Today we are going to start a very important topic which is dynamics. In our previous unit, we mainly discussed how objects move. We described motion using quantities such as displacement, velocity, and acceleration. But today we are going to one step further. I want you to think about this question. Why does an object start moving? Why does it stop? Why does it speed up or slow down? For example, look at this car. If the car is moving forward, something must be responsible for changing its motion. Similarly, when the driver applies the brakes, something causes car to slow down. That something is related to force. Okay. So, in this unit, we are going to understand the relationship between force and motion. Begin with the most basic idea. What is a force? So, in physics, it is the invisible push or pull that changes the motion, shape, or dimension of an object. Here I show you three different images. In first picture, you push something to object and object is starting to move, okay, with this in this direction. So you apply some force on this object and it will come into the motion. In the second picture, I show some when you pull something. So when you pull something and it is like elastic, it will elongate like this, okay, and it is also a force, okay, this is the kind of force. And the third one, we all know in earth there is a gravity on every point of earth. So there is a if any object having a mass m, so it must having some force due to the earth, and which we are call it as a gravity. So this is the basic understanding of the what is a force. And you know the every quantity which is distinguished by it is a vector or a scalar. So what is a force? Is it a scalar or a vector? So the force is described by the magnitude as well as the direction. Okay, the direction in which the force is applied to an object. Okay, that means the force is vector quantity. And the SI unit of the force is Newton, which is denoted as N, capital N. Okay, you to consider these scenarios. So, where we are trying to understand that what is a friction. So, in order to understand the friction concept, let us imagine these three scenarios. In the first, imagine I push a box across a normal surface. After some time, the box will be stopped. Why does it have stopped? Okay, there must be a force acting on that this box. It will do some kind of deceleration. Okay, we know the concept of deceleration. So it may stop. after some time. And consider the second scenario, in which we are going to take as a friction as low side. Okay, means consider in this case the friction is like 100 magnitude, and in this particular case we have a it is magnitude about 50. So what is the difference of these two cases? So in the second case, we will notice that the box will travel a greater distance compared to the first case. In the third case, we completely remove friction. That means there is a no zero value of the friction. So in that case, the box will continue its motion with initial velocity. So there is no you can say obstacle or the force is trying to box to stop. Okay, so this means an object doesn't require a continuous force to keep moving with constant velocity. This idea is the basic of Newton's first law. So this is a clear, it is a kind of illustration to understand the friction. And this friction is going to give some idea of Newton's first law. Okay. So now we are going to see and understand what is Newton's first law states and what is its significance. We are going to understand the Newton's first law. It contains some important quantity, or you can say inertia of motion. So if you want to understand the Newton's first law, it is basically you can say inertia law. So in first law says every object continues in its state of rest or with uniform velocity unless acted on by a resultant force. So let's understand this with an example. Suppose a heavy box is lying on the floor. It will remain at rest unless a resultant force acts on it. This is related to inertia of rest, you can say. Similarly, if an object is already moving, okay, some kind of velocity it may have, it tends to continue moving with the same velocity. You can say a constant velocity unless a resultant force acting on it. This is related to the inertia of motion. Here I show you two pictures. In the first case, it will show inertia of rest. Like you can see the big rock is stationary, okay, unless the resultant force acting on it, okay. In the second case, this you can say this striker is moving this velocity. You can say in p velocity it may have, and it has the same velocity unless the force resultant force acting on it. So so there is an important relationship between inertia and mass. So let us try to understand here what is the inertia. Inertia is the property of an object to resist any change in the velocity. So in this, the big rock is at rest, so it stay in at rest until it come across some kind of resultant force. In the second case, the striker is going to same velocity unless it experience some force, external force. So that means here we have a mass and inertia. It is kind of related or not. In order to understand the relationship between mass and inertia, I have one statement. Means The greater mass has greater inertia. It's a one statement. It gives a clear idea of mass and the inertia. For example, let us more difficult to push or accelerate a football rather than heavy truck. Means if you have a football over here and the one you can say tennis ball over here. If you want to push for something that you want to do force on this ball, you take some extra force. You need some energy more than to move this ball, which is small ball. Okay, let's suppose you have a bicycle and truck. If you push the bicycle, so bicycle has is easily moved by you. Okay, one people. But in order to you have to push a truck, you cannot easily push this the truck. Okay, you need some extra force. Okay, so truck has a bigger mass or larger mass, and the bicycle has lower one. Okay, so the final I want to summarize this because the truck has greater inertia because it has greater mass. That's it. So Newton's first law says the, the force acting on the particle or body is going to at rest or in the same motion unless it is experience some resultant force. So this is the brief introduction about force and how it relates with the masses. Okay, so this is the Newton's first law, right? Things keep doing what they are doing. Okay, now we move forward to Newton's second law. Now, in the first law, they give us some kind of statement of in terms of inertia. Okay, in the first law, we understand the definition, some kind of definition of it. But in the second, uh, you can say law that describes the mathematical framework, or you can say mathematical formula of a force. It gives you a formula. So what is it? We read for an object of constant mass. We deal with the constant mass in the our classical mechanics. In classical mechanics, we generally deals in the constant mass. But if you enter in the quantum physics or quantum mechanics, it should be not a constant mass everywhere. Okay, but here we can take as a constant mass. Its acceleration is directly proportional to the resultant force applied to it. So what does it mean? The force, its acceleration is proportional to the force, like this. And you know, instead of using this, if you use equation, so you need some add some constant over here, and this A. And this constant is mass, because we have seen that in the first law, the force is also depend on the mass, okay, inertia. So here I write the formula force. Let us identify the one by one variable. Force, the push or measured in newtons. As I say you earlier, that force has a unit in newtons. And the mass, is measured in kilogram. The SI unit of mass is kilogram. It is, you can say here, it is resistance because we have already told you that the inertia is a play important role in it. And acceleration is measured in meter per second square. The change in speed, as we have defined, is dv upon dt, the fractional change of v with respect to time. Okay. Now they give some scenario. If you're pushing a 1.5 kg cart, they given a mass. Okay. Let's suppose this is a kg, and with a 3.3 Newton force, and they give a force as well, 3.3 Newton. Now, what we have to find that what is the acceleration of that card? So use this simple formula over here, and you will get A. Okay, this is a 2.2 meter per second square. Now you can easily understand. So what is the cause of A? Here, the cause of A acceleration is force. The velocity is changing because A is over here. Why A is over here? A is over here because the force on the body acting. Okay, some kind of force it is experiencing. That's why I told in my previous video we are going to define the why the V is changing. Okay, and why we have A should be introduced because it's some kind of force acting on the body. So I hope you understand Newton's second law. Now we are move forward in Newton's third law, and it is one of the most interesting law. Look at the rocket as shown here. The rocket pushes the gases downward. Here you can see the gases at the same time. The gases also pushes to the rocket upward direction. Now here I use object B, gases, pushes object A, rocket. Let's suppose here is a rocket, it is going upward direction and the gas is going this direction. So the force due to this gases on the rocket, let's suppose I write object A is a rocket and object B as a gases as I mentioned here. So force due to on the rocket due to the gases is equals to the force on the gases exerting by a rocket, and it will be same magnitude but in the opposite direction. This is the Newton's third law. Okay, here I write object A rocket pushes object B means gases downward direction. And here I write the two forces act on different objects. You should understand the I write here this and this, the negative opposite direction. This force acting on A body, this force acting on B body. Some students might get confused. They treat it as the both forces acting on the same body, but here it is different. The both forces acting on different bodies. Okay, so you can say the action and reaction forces act on different objects. If you let's suppose if you say this is the action force and you can say this is the reaction force, it will be the same magnitude but opposite in the direction. Okay, this is the third law states. Let's take some another example. If I push a wall, does the wall pushes me back? The answer is yes. Okay, and one thing you should remember that the action and the reaction are equal and opposite, but they act on the different objects. That's the main heart of the Newton's third law. If you understand this easily, you can easily apply this law in every mechanism. Okay. You can easily this apply this law in the way when we are doing some examples. Okay, if you don't know how we put and what is the action, force, reaction, force, and if you didn't understand the theory well, so you cannot apply in the examples or problems and the questions. So we have seen third one, two, and three laws of the Newtons. So let's summarize it. First, we have seen how the force is caused every change. Okay, it might be for in motion. So that means if body is going this direction, some kind of force acting on it, and maybe velocity is changing, or you can say the direction of the object is moving is changing, or the shape. Let's see in the second photo, the force is applied in such a way that the object has different shape, got a different shape, and the dimension as well. So this is the basic of the force. And then we have a learn about the friction concept. Okay. So what is the effect of a friction on the body when the body is going on the some surfaces? Okay. Then we have a see so that the word is a first law. And first law says the inertia is most important for it. When you do some kind of force on that body means greater mass has greater inertia. That means if you have a bigger mass, if you want to move that mass, you need some extra force. On the other hand, if you have some small ball, you need some small force acting on it to give some speed. So this is kind of first law. In the second law, we have seen and we understand the formula, okay, mathematical framework of the force. And we have done one example of it. And the third one, but not the least. So it says force acting on the body have a same means B body is acting on A at the same time. One more thing I have to add, it's at the same moment, at the same time. Not for the one is at the t is equal to 1 second experiencing some force FAB, and then after some time it will be 5 seconds. The B object is going some kind of getting some force. No, it's not. They experiencing same force at the same time. Okay, so keep in mind the forces are same, but in the opposite direction, and the both forces not in the on the same object on the different objects at the same time. I hope you understand the Newton's first, second, and third law. In my next video, we are we will see some other quantities as momentum. So what is how the momentum is correlated with the force, and then we have some kind of misconception between weight and mass. Some people or some students might get confused that they are both same quantities. No, it is not. At least in the physics, they are not the same. Okay, we will see in our next video. And okay, so we will see this in our next video. So I hope you are doing reading some concept of physics and you have to revise these three laws because it is very important when you deal with some examples we will solve in our next videos. In the problems you have to apply. The application part is very important. if you know Newton's first law, second law, and third law, but you don't know how to apply this formula and the concept on each problem, so it is not fruitful to you that it is you have learned the physics. If you want to learn the easy way, first you need to theory to understand, okay, to recall, and then you have to apply on the problems. So we will see the problems as well. So I hope you guys like my video, and these three laws are very important laws. So thank you for watching. Subscribe for more physics lectures.